Hello everyone. So previously we had discussed on the topic segmented shape algorithm. Yeah. So today we'll be discussing on the topic Euclidean algorithm. Yeah. For the GCD basically, right? To calculate GCD. Now let's get into the definition part here. So what does the definition part say here? So the Euclidean algorithm, it's a method to find the greatest common divisor, GCD of the two integers. Yep, this is fine. So it works by repeatedly replacing the larger number with a remainder, right? So this part is very important. It works by repeatedly replacing the larger number with a remainder when the larger number is divided by the smaller one. When larger number is divided by the smaller one. Yep. Until the remainder becomes zero. We'll be continuing until the remainder becomes zero. This is fine. Now, let's move on with the explanation part, man. So what's the idea basically? The idea behind the Euclidean algorithm is that, see, the first step here, so just listen to this carefully. This is the same thing that we'll be articulating in the form of code. So the GCD of two numbers A and B. So we'll be going with two numbers A and B, right? So the GCD of two numbers A and B, where A is greater than B. So suppose A is greater than B is the same as the GCD of B and A modulo B. B and A modulo B, right? So this is fine. So this is because if the number divides both A and B, so while we consider the example, you'll come to know this is because if a number divides both A and B, it must also divide the difference, right? Or remainder or remainder. By repeatedly applying this rule, we reduce the problem until one number becomes zero, the same as this one we discussed in the definition part. The other number then is its GCD. The other number then is the GCD. Sorry. Yep. So let's try to articulate the same thing in the form of code actually. Let's try to implement the same thing here in the form of code. So we'll be making use of the Python programming language. Yeah. So first thing, so here let me go with def GCD, function name GCD. So let me go with two parameters A and B as per the explanation, right? As per the this one discussion that we had done earlier within the explanation, right? So now, first let's do one thing. Here we are defining a function GCD, right? Taking the numbers A and B. Now let's repeat until B becomes zero, meaning while B not equal to zero. Simple, very simple one. Next, let's replace A by B and B with the remainder A modulo B accordingly with the accordingly with what we had discussed in the during the explanation part. Yeah, now I can just write it in this way. A, comma, B equals B. This is one thing. And finally, A modulo B. Yep. So this is fine. So the next part would be the simple one. All we have to do is we have to return A, meaning when B becomes zero, then we have to return A as the GCD. This one we had discussed, right? So let's return A here. Let's return A here, right? So this is simple, man. So this is it for the algo. This is it for the algo, right? So let's go with the example usage here. Suppose let's consider here num1 equals some random number. I'll just give 48 here, right? 48. The numbers, some random two numbers that should be divisible by at least some of the right 4, 6, 7, something like that, right? Both the numbers that are divisible by some number, particular number. So let's initialize second number as well. So I'll just go with a num2. Let me consider 18 here. So this is fine. Right. So now let me consider the variable result. Let me call the function GCD here of let me pass two numbers num1 as well as the num2. Yep, this is fine. Finally, let's print something for the interactiveness. I'll just go with the print GCD of. So here this will be let me pass num1. This is fine. Let me go with and here. Let me pass num2. This is also fine. Mm, Now I'll just go with these here. This is fine. And finally, let me go with the result. Let me go with the result, meaning we have to print the final GCD. Yeah. So this is fine, I believe. We have just initialized the first number. This is the example usage actually. Yeah. Initializing the second number. We have initialized the second number. So we are calling the GCD function and storing the result here. Line number 24, 25. This one, we are just printing the final GCD. Yep. So I hope algorithm is completely clear, right? So we have I have explained this one step by step. Right? So this is fine. So if I run the code, what is the output that we need to get here? See, GCD of 48 and 18 is 6. Right? So GCD of 48 and 18 is 6. Both are divisible by 6, and it is the greatest common divisor. You can just check. Yeah. So GCD of actually num1 we are displaying 48 and num2 here this is 18. GCD of 48 and 18 uh, is we are giving is nothing but 6. This is the output that we need to get, because see, accordingly with the algorithm we will start with the numbers 48 and 18, right? So our input that we have considered is 48 and 18, a and b respectively. Yep. So inside the loop that we have considered here, um, inside the while loop actually, inside the loop, so first what we'll do, we'll go with a 48 modulo 18. Yeah, 48 modulo 18, that is nothing but 12 here, right? So this is nothing but 12 here. So now A equals 18, A remains 18 and B remains 12. B becomes 12 actually, sorry. Now what we will do, we will go with 18 modulo 12 here, right? 18 modulo 12 here. So now this will be 6 actually. Remainder will be 6 actually. Yeah, 12 ones are 12. 12 into 1, 12 actually. So basically 6 will be remainder. So 6, now what we will do, now A will be 12 and B will be 6. Now A will be 12 and B will be 6. So what we will do, we will go with 12 modulo 6. 12 modulo 6 and this will be 0. 12 modulo 6 will be 0. Now what we will do, A remains 6 actually. So this one, A remains 6 and B is 0 because remainder is 0 here, right? So we will carry on until remainder or B becomes 0. So that's what we discussed in the explanation part, right? So now B is 0 and A is 6 will stop over here, right? So when B becomes 0, loop ends, right? Basically. So the final value of A is 6 and we got 6 here, basically. Final value of the A is 6 and we got 6 here, which is the GCD, which is the GCD. So the output that we need to get here is 6, basically. This is why we need to get the output 6. Yeah, very simple one. Now we have discussed the output part as well. Let's do one thing. Let's quickly run the code, man. I'll give control J here, Python followed by file name dot py. So yeah, GCD of 48 and 18 is 6. We are getting the desired output, man. Yep. So whatever the algorithm that we have written works absolutely correct. Yep. So this is fine. Now, as we're done with the algorithm part, let's do one thing. Let me summarize whatever we have learned so far. Just try to remember these 2 to 3 points, man. This is very important actually. I found this very important. So let's discuss the same actually. The Euclidean algorithm, first point here, the Euclidean algorithm efficiently finds the GCD of two numbers, right? So efficiently finds the GCD of two numbers using repeated divisions, right? Using repeated divisions. We know this one. Now, the second part is, what is the time complexity here? The time complexity of the algorithm that we have written as big O of log of min of a comma b, min of a comma b, the numbers a comma b, right? So this is fine, I believe. So this is the time complexity actually, right? Making it very fast even for large numbers, right? So this is fine. The final point would be, it's the foundation of more advanced algorithms, whether it may be like computing this one LCM, right? Least common multiple, right? So lowest common multiple. So least common multiple or lowest common multiple? Least common multiple, right? So yeah, haven't used this term at all actually, LCM, since many days. This is fine. It's the foundation of more advanced algorithms like computing LCM, least common multiple, or working in modular arithmetic. So next we'll be going with the modular exponentiation and other algorithms as well, right? So we have to know this one, yeah. So we'll be making use of the GCD there, yeah. We have to know this algorithm at any cost. So this is one of the simplest algorithms, yep. So again, it's the foundation of more advanced algorithm, whether like to compute the LCM or working with the modular arithmetic, right? Right? Or working in modular arithmetic. So these are one of the three important points that I found, and I wanted to discuss with you guys, right? So this is fine, I believe. Now we are done with the Euclidean algorithm. Yep. So next we'll be discussing on the extended Euclidean algorithm. Extended Euclidean algorithm. Yeah. For now, this is it. Thanks for watching, guys.